All right, this is section 3.3 on systems of inequalities. Now, graphing systems of inequalities is just like graphing systems of equations. You just graph each line individually. But sometimes you're going to need a solid or a dotted line, and you're always going to need to shade when it's an inequality. So here's what you need to know. It is going to be a solid line when it is greater than or equal to, or when it is less than or equal to. If it ever says equal to, you're going to need a solid line. Okay. The dotted line is when there is no equal bar. It is simply greater than or it is less than. It is not equal to. And now, as far as the shading goes, sometimes you're going to shade above, sometimes you will shade below. And I teach this a little bit differently than your Algebra 1 teacher and maybe even your geometry teacher did. Most of them make you choose a test point and plug it in to see if it's true or false. There's an easier way. If you will always get your equation so that y is on the left of the inequality, there's a super easy way to figure this out. Okay? As long as your y is on the left side and it says greater than or it says greater than equal to, you're going to shade above. You get your y on the left and it says less than or less than equal to, you're going to shade below. Yeah, Jackson.
So is it basically the same principle of like graphing inequalities on a number line, where it's like, you know, there's
A solid dot versus an open dot? Yeah, it is. It's exactly the same.
Okay.
Yeah, the only thing we've got different here is the shading. It's going to be above and below instead of left and right. Yeah. So now, I don't know if anybody printed these, but I'm going to alter one of the problems we're going to do. So in the first problem we're going to do, and I'm going to scoot this up a little bit because I see some of you are still copying. These are the two inequalities we're going to work with. And originally, both of them were greater than equal to. I changed this first one so that it's just greater than. And you'll see why in a minute. Okay, I want you to have one of them with a solid dot or solid line and one of them with a dotted line. So what we've got to do with these inequalities, just like we did with the lines, is we've got to get them both in slope-intercept form. So again, I didn't leave myself much room, so I'm going to work over here. Take 2x minus y is greater than negative 3. First thing I'm going to do is move my 2x over. Then I have to divide everything by negative 1. But when you divide by a negative 1, it flips your inequality over. That's the part that a lot of people forget. So flip my inequality over and changed all the signs.
If you multiply by a negative 1,
It's also going to change it. If you multiply or divide both sides by a negative number, it will flip that inequality over. Okay? So now, let's go ahead and graph this one before we work on the next one. So my y-intercept is 3, so I start at 3. My slope is the number in front of x, which is 2. Remember, slope's always a fraction, so it's 2 over 1. So from that y-intercept, I'm going to go up 2 and write 1 several times. Is this going to be a solid or a dotted line? Dotted because it does not say equal to. Okay. And now we have to shade it because this is less than. My y is on the left side and it is less than. I'm going to shade underneath. So this is the part I would need to shade. Okay. For the other inequality, it's already in slope-intercept form, so I'm just going to graph it. That one will start on the y-axis at 1, and from there, you've got to graph your slope. And remember, that negative can go on the top or on the bottom, but not both places. So I'm going to put it on the top. I'll go down 1 and write 2 several times here. Will that one be a solid or a dotted line?
Solid.
Solid because it has that equal bar. So for that one, my y is on the left and it says greater than or equal to, so greater than shades on the top. So where are your answers? Well, and it's not all of quadrant 1, it's a lot of it. But what we're looking for is where the overlapping shading is. And here's where you've got to be careful. This first line I drew in here, the pink one, it is not part of the solution because it's a dotted line. The blue line, the second one that I did, it is a solid line, so any of those points could be a solution, as well as any point over here. If you pick any of those points in the shaded, in the overlapping shaded part, you can plug it in here, it'll make it true. You can plug it in here, and it'll make it true. Okay. And so when I'm not graphing for you guys, I don't usually graph in pen, just because I sometimes make a mistake. I usually graph in pencil, so the overlapping part is just shaded darker, which is fine. You know, sometimes with the pens, things get a little bit messy looking, so pencils might be easier, but if you like pens, that's fine. Any questions on this one? I'm still working on this one. All right. There's one here that I want you to try on your own. Okay, I'm going to freeze the screen and pause the video while you work it. I'll work it here and then we'll turn it back on and see if you have questions. Alright, so here's mine. Check it with yours. Let me know if you have any questions. You okay over there? Alright, so this last one that we're going to do is another system of inequalities, but I want you to look at the two inequalities. You've got one that's just a line, it's linear, but then this absolute value one. It's been a while since we've done absolute value. Yeah, it's going to be a V shape. So let's graph that one first, and then we'll do the line because it's easy. So this one already has y by itself. I know this is going to be a V shape because it's absolute value. What does this -1 inside the absolute value do to my vertex? It's going to go to the right one. Stuff that's inside moves it left and right, but I do the opposite of what it says. So from the origin, I'm going to go to the right 1. And now we've got to make the V. In front of my absolute value, there's not a number, so it's understood to be 1. Go ahead and make it a fraction, put 1 over 1. And what you're going to do from that vertex right there, let's see if I can make this a little bit bigger. You're going to go from here up 1, both directions 1. So from here, I go up 1, right 1, back to that vertex, go up 1, left 1. So that's enough where I could draw in the V, but if I wanted to be more accurate, I could work on both sides a little bit more. So back to the right-hand side from the vertex, I went up 1, right 1. Continue to go up 1, right 1 a few more times. Then go back to the vertex and go up 1, left 1 several times. Again, just to make your graph more accurate. Is this V going to be solid or dotted? Solid. And so when we get ready to shade for this, we're going to shade just like we did for the lines. Because this is greater than, I'm going to shade on top. Okay, we're not doing inside and outside the V, we're doing on top of or underneath. Yeah.
How come your vertex isn't at -1, 0?
Because remember when it's inside, we do the opposite, and it goes left and right.
Oh, okay.
If it comes after the absolute value, that's when it shifts up and down, and we do the same as the sign. Do you remember when we did that with parabolas way back when? It follows the exact same patterns. So this is greater than, it's going to shade on top. And now for the one that says y is less than or equal to 3. What is that going to look like when you graph it?
Straight line on green.
Well, aren't all lines straight? Yes. What kind of straight line?
Horizontal.
It's a horizontal line that touches the y-axis at 3. Y'all do that every time for me. What kind of line? Straight line. They're all straight. All right, so where do I shade? On top or underneath? Under. So where my overlapping stuff is inside that little bitty triangle there. Are the sides of the V and that part of the horizontal line, are they included in the solutions?
Yes.
Yeah, because they are all solid. Okay. So that's it for 3-3.